This is the first video in the AWS Developer Series, Secure Application. Krypto Manager is a tool that's designed to work with an AWS application that will automate AWS actions on artifacts like S3 buckets or IAM user permissions. The application that Krypto Manager complements will use AWS SDKs with IAM user credentials. When setting up an application that depends on IAM keys, you have this one-time operation to obtain the raw keys from IAM. We quickly and easily encrypt the raw keys with Krypto Manager, then we delete the raw keys. The encrypted keys only will then exist in the source code. We can break down AWS security into two broad categories. Internal to AWS. This is the communication and policies that exist inside AWS. Then we have external to AWS. Just to outline what we loosely mean by internal AWS security artifacts. When AWS services communicate and interact internally, they use what are known as STS credentials based off IAM roles. We can keep a handle on what credentials are being used internally with a useful tool called CloudTrail. When we set up an EC2 instance, we have an SSH configuration for the EC2 box, that is, we would typically disable password authentication, and we would set up a security group to whitelist IPs and disable various ports. External to AWS are the things that are under our control. As humans, we make mistakes. High on the list of these issues are what's known as credential compromise and social engineering attacks. This is where the Krypto Manager source code can help. The links below illustrate related issues to AWS. Krypto Manager is set up to allow the following: to encrypt these raw credentials with a strong secret key protected by a strong key store paraphrase, to easily encrypt the account ID and any other data that opens up social engineering attacks, and make all this easy and repeatable and facilitate credential rotation. First, we call AWS IAM for the security credentials. These come into Krypto Manager, but they don't exist in the file system. They're encrypted and we put them into the source code, protect them with gitignore just as we would if they were unencrypted. We can put the encrypted credentials and other sensitive data, such as account IDs, into the source code in their encrypted form. Now we look at the runtime situation. This is where we are using the application that's been protected by Krypto Manager in terms of credential compromise. So we start with the user entering a strong paraphrase. Then the decryption will occur in a decryption method which will run in the stack on the JVM, and the raw credentials will be persisted in memory in the heap on the JVM. If they decompile the source code, they're only going to get the encrypted credentials. If they can hack the Git repository or SVN repository, they're only going to get the encrypted credentials. If the attacker obtains access to the credentials as they are encrypted and the paraphrase is stored in a password manager without expenditure of considerable resources, they will not be able to decrypt the credentials. Now we will demonstrate how you can use the Krypto Manager to set up secure credentials for an application that uses an AWS SDK. Now we will run the code from source against local stack. First we need to set up an in-memory key store. We boot up our Krypto Manager and we notice that the first option is only to create the key store, and so we need a paraphrase to lock down our secret key. So now we go to our password manager to obtain our auto-generated strong paraphrase. Paraphrase is locked down and very secure in the password manager. So now we pass our paraphrase into our Krypto Manager to generate the key store. This will generate the JSON. We've now generated a key store containing a secret key that's locked down with a very strong paraphrase. So we copy this into the appropriate configuration file. Now that we've created this in-memory key store for the target application, it's time to encrypt the SDK credentials. So we go to the management console to obtain fresh credentials for IAM. We will encrypt these credentials with the key store artifacts, the secret key that we just set up in the target application. We will encrypt the credentials with the same security artifacts, so at runtime they can be decrypted successfully. Let's rotate the credentials, so we delete the existing credentials. Now we create new credentials. This is a one-off operation. So we download the CSV file, but open in a text editor, so we're not going to save them to the file system. Now we're going to copy and paste these credentials into the Krypto file manager application so they will be encrypted. So we copy the artifacts into the application, perform the encryption, and now we copy the encrypted credentials into the appropriate configuration JSON file in our target application. The target application runs a login process with Amazon Cognito. So we need to encrypt our Cognito artifacts. We need a pool ID, we need an account ID which we can easily obtain from the ARN, we need a client ID. And we obtain our client ID. Now that we have all our Cognito related artifacts, we encrypt those artifacts into a JSON file which we can copy into a configuration file as before in our target application. Once we set up our Cognito JSON configuration file correctly, we're ready to run a test of the target application against LocalStack. So we have LocalStack running, offering an S3 service. Now we log into our application running against LocalStack. So we go to our password manager, copy our strongly protected and strong paraphrase. The paraphrase unlocks the secret key so we can decrypt the credentials at runtime. So we're running against LocalStack, so we will check that our SDK operations will work by creating a bucket. So this application can create, delete buckets, list objects in buckets. So it can just manage day-to-day S3 operations, uploading a file, deleting a file, downloading a file from S3. This means that our in-memory key store is unlocking the secret key with the provided paraphrase, and that secret key is running in the code that decrypts the credentials without any bugs. So we update the code now so the code will run against AWS. So we boot up the code. We use the password manager to protect these artifacts in the file system. So our paraphrase and our Cognito login. So we use the paraphrase to unlock the encrypted artifacts from those configuration files. So everything's set up and we're going to log into AWS via Cognito. So this login took a bit longer against AWS, but we could see the buckets. This means everything worked out. A scheme of protecting the credentials with encryption at runtime, not storing any raw artifacts outside of a password manager strongly protected by a file system key. No raw or unencrypted credentials have been stored on the file system at any time, but it's important to clear everything even out of memory. So we have a reset button that will reset all the fields. We have some validation. This comes from the TornadoFX framework. Just a quick mention about the code that creates our crypto manager. We're using Kotlin and the TornadoFX library to create this GUI, and it has a lot of things that you get for free, such as validation for required fields, as you can see here. We're using AES, Advanced Encryption Standard. We're using a 64-bit SOL from a secure random number generator. We're using initialization vectors. So we've covered the basics. Follow this link to get more details about the encryption scheme. Given enough time and resources, a sophisticated attacker can bypass many formidable security systems. Our goal here is just to buy enough time. In the event of a breach, we can recover the situation before all is lost.